Okay, so 5.1 is going to use, it says using fundamental identities. We're just going to use trig functions to solve problems. You have used trig functions to do this. It's a review. It's been a long time, okay? It's a review of the identities before you start having to prove them starting Friday. So these, come on, you can do it. There you go. You should have all of these written on the top. You should have them already written in your notes at somewhere. If you want to go and write every single thing on this piece of paper, it is in section 5.1 in your textbook. This chart is, okay? I'm not going to sit here forever for you to write them. But remember, sine is 1 over cosecant, correct? Yeah. Just like cosecant is 1 over what? Sine. Those are called the reciprocal identities, correct? Okay. Then we have tangent is sine over cosine. Cotangent is cosine over sine. Reciprocal identities again. We have our Pythagorean identities. These are ones you're probably going to have to spend some time with again. Sine squared plus cosine squared equals 1. Remember, we found that, and then we changed it into the other two. So I have 1 plus tangent squared equals secant squared. And what is in the denominator of tangent? What function?
Sine over cosine.
Okay, so it's cosine in the denominator of tangent. What is in the denominator of secant? Cosine. So that is why tangent and secant are paired. So 1 plus cotangent, well, what's in the denominator of cotangent? Sine. So cosecant, sine is in the denominator. So these are the Pythagorean identities. Now we talked about cofunction identities. These are written a little different. Remember, if things are complementary, that means they equal what? 90. So if the two angles are complementary, the sine of one is the cosine of the other. So that's all this says. This is a really weird way to look at it, but it works. So it says sine of pi over 2, which is 90, yes? Minus the angle is the cosine of that u. Just like the cosine of pi over 2 minus u is the sine of u. So these two angles, I could write on here, not just point. These two angles here and here are complementary. They equal 90 degrees. So the sine of the one is the cosine of the other. That's all that's saying.
Wait,
you
so
are.
If it was, like, let's say cosine of pi over 2 minus, let's say, 60 degrees, then what would be sine of?
Okay, so cosine of 60, yes, is 1/2. And that means the sine of 30 is also what? 1/2, because they're equal. Because 30 and 60 are complementary. So the cosecant of 58 is equal to the secant of what? 32. Because 32 and 58 are complementary. Make sense?
Does it just have to add up to 90?
Yes.
Okay.
That's what complementary means.
Don't be mean.
I don't listen very well.
I know. So this way they have it written is very confusing to me. Yes? Okay. But does this make it clear?
Yeah.
Okay. So the last one down at the bottom are even and odd identities. We've talked about it a little bit, but I am going to give you time to write this down because I don't know if you've written it down. And I'll explain why it is in a second. The sine of a negative angle is equal to negative the sine of the angle. The cosine of negative an angle is equal to cosine of the angle. Tangent of negative theta, they use a u, okay? U is the same thing as theta. It's just an angle. Is equal to negative tangent of u.
All FDLA members, please report to Mrs. Schluter's room now.
Okay, so you notice that the sine and cosecant are the same, correct?
Yeah.
Because they're reciprocals. We're talking about positive and negatives. Cosine and secant are the same because we're talking about what? Positives and negatives. And then tangent and cotangent are the same because they're reciprocals. And again, we're talking about positives and negatives. Now I'm going to show you what this means. So here is my coordinate plane. Yes?
Yeah.
If I'm talking about cosine, when I go around my circle, cosine is positive in the first quadrant, correct? Negative in the second, negative in the third, and positive in the fourth. That's if I'm going a positive direction. So when I do that, I have positive, negative, negative, positive, positive, negative, negative, positive. I could keep going in a circle, right? What if I stop and go the opposite direction? I still get what? Positive, negative, negative, positive. Do you see that? So cosine is the same in a positive angle or in a negative angle. That's why the cosine of a negative angle is equal to cosine of that positive angle. That is why it's even function. Cosine is considered an even function. Because if I go positive, I get positive, negative, negative, positive. Positive, negative, negative, positive. If I go negative, I get a what? Positive, negative, negative, positive. Is it the same way, either positive rotation or negative rotation? Yes. Okay, now tangent and sine are both considered odd functions because I have, we'll do sine first. I have positive, positive, negative, negative. Is that going to be the same in a positive rotation as a negative rotation?
No.
No, it's going to be the opposite, isn't it? So with sine, I have positive, positive, negative, negative when I'm doing a counterclockwise, or negative, negative, positive, positive. So that is why the sine of a negative angle is equal to negative the sine of the positive angle. And what that means for you is basically the sine of negative 30 degrees is equal to the negative the sine of 30 degrees. Which you should know the sine of 30 degrees is what? 1/2. So it's negative 1/2. That's what that means. Yes, it is. 30 degrees is pi over 6. So tangent. Can I erase my sine drawing?
No.
Too late. Tangent is positive, negative, positive, negative. Correct?
Yeah.
So if I go a positive rotation, I get positive, negative, positive, negative. But if I go a negative rotation, I get what? Negative, positive, negative, positive. Do I get exactly the opposite?
Yeah.
Yes. So that is why it's considered an odd function. And the same thing would happen as with sine. It does come in handy because then when it does, it gives me a negative 120 degrees. Do I have to think about a negative 120 degrees? No. I can just do, I can do the negative and then just do 120 degrees. So it makes my circle from infinitely large just down to one rotation.
It's just large.
It's just large, not infinitely large.
So what do you mean by do the 120 degrees?
So if I had, let's say the sine, actually I'll do tangent. We'll go through the whole thing. So tangent of negative 120 degrees. Okay? So that is going to be equal to negative the tangent of 120 degrees. So I'm going to write on my negative 120 degrees. What's your reference angle? How far is it from? Well, first of all, 120 degrees, what quadrant is that in?
2.
2. So is tangent positive or negative in that quadrant?
Negative.
Negative. So I'm going to add another negative, right? And then what's my reference angle for 120?
30. Because like from
120 to 180. 60.
60.
So I have negative, the negative tangent of 60. Well, the two negatives out front is going to be what? Positive. And then tangent of 60, what's opposite of 60? No, what ratio is opposite of 60?
Square root of 3.
Square root of 3, so it's square root of 3 over 2. So that's how you would use that. Is that what you needed, Ethan?
Yeah.
Okay.
Just to figure out
Just to see
what,
it.
what you meant by solve the,
Right.
solve the 120.
Okay. So go ahead.
When you get the tangent of 60, will you always take it from 180 degrees?
Yeah, the reference angles are always from the x-axis. So this is 180 or 360. Okay. So now let's do a couple of examples. I just have a couple because there's like so many problems I could do. Oh, real quick, the Pythagorean identities, you will need to think of them as this because it started with sine squared plus cosine squared equaled 1, yes? That was the original Pythagorean identity. How did I get to what I have here?
Square root of both sides.
Not first I did what?
Oh, you subtract.
I subtracted the cosine, right?
Mm-hmm.
And then I had to take the square root because I don't want sine squared. I just want what? Sine.
Mm-hmm.
So if I had cosine of u, what would it equal? Plus or minus what?
The square root of 1 minus sine u.
Yep, sine squared u.
Sine squared u.
Okay, so I can move it around. So if I don't want the squared of it, I would have to take the square root. Now, the next example I have was the tangent. So that started with 1 plus tangent squared of u equaled secant squared of u. So they subtracted the 1 over and took the square root. Now, you notice there is a what in front of these?
Plus or minus.
Plus or minus. How do I determine the plus or minus? How do I determine any time the plus or minus?
The quadrant plane.
The quadrant the angle is in. Okay, so the quadrant this u falls in determines whether it's positive or negative. Okay, ready for the next?
Yeah.
Okay, so it says use identities and the values secant of u equals negative 3 over 2 and tangent of u is greater than 0. Okay, so it says secant is negative. Hello? Hey. I'm teaching. Okay. Bye. Okay, so it says that the secant is negative, but the tangent is positive. So I need to figure out what quadrant I'm in, right?
Yeah.
Okay, so let's see. Oops, pin. So here's my little quadrant, right? So if I'm talking tangent, I have positive and positive, correct? So which one of those quadrants is secant negative in? 3, because nothing is negative in 1, is it? So what quadrant are we in? Quadrant 3. So that's important to know so we can, it's important to know so we can figure out positive and negatives on all the other functions, okay? So if I know secant, because it says use identities, so I can't draw myself a triangle. I got to use my identities. So if I know secant, what do I automatically know?
Cosine.
Cosine. Because cosine of u equals 1 over the secant of u. And this is how you show me you're using your identities, because did I just write the identity?
Yes.
Yes. So that means reciprocate it, correct? So what is the reciprocal of negative 3/2?
2/3, negative 2/3.
Okay, so negative 2/3.
And that's the
Nope, we can't do a triangle. It says use identities.
Square.
So I have secant. What other function is secant involved in? What other identity is secant with another? Do you have your Pythagoreans?
Pythagorean.
Is secant involved with another function in their Pythagorean?
Cosecant.
Secant is 1 over cosine. Cotangent or tangent is cosine in the denominator of?
Cotangent.
Cosine in the denominator.
Oh,
That would be tangent, correct?
Yeah.
So we know that 1 plus tangent squared equals secant squared, don't we? Do we not? We know that? So we need to get tangent. So how many is this to get tangent?
Subtract 1.
Subtract 1 and take the
Square root.
square root. So tangent of u is going to equal plus or minus, but is it plus or minus? Which one?
Plus.
Plus, because it tells me it is, right?
Yes.
So it's plus the square root of 1 minus the secant squared. So now I just fill in. So I have the square root of 1 minus, we'll square your secant right there. So what's negative 3 halves squared?
Square. I don't know.
What's 3 squared?
9.
9. It'd be 9/4. And 2 negatives make a positive, but it's still going to be minus because the problem's minus, right?
Yeah.
Okay, so now I need to get common denominators. So 1 is going to be what? 4 over 4. So I'm going to get 4 minus 9. I wrote that wrong. This is not right. What'd I do wrong?
Oh, you put the 1 in front of each.
I put the 1 in front and it's not. It's secant squared what?
Minus 1.
So it's secant squared minus 1. Sorry. No, but that makes a difference because we had the square root of a negative number. Can you take the square root of a negative number?
No. Man.
No. So we had 9/4 minus 1, which would be 4 over 4. So that'd be the square root of 5.
Over 4.
And what's the square root of 4?
2.
2. So the square root of 5 over
2.
2.
I'm on it.
Okay? So now that we have tangent, what can we find?
Sine.
Cotangent, because it's a reciprocal, right? Okay, so cotangent of u equals 1 over the tangent of u. So we're going to reciprocate, and it's still going to be positive.
Yeah.
So it'd be 2 over the square root of 5.
Gotta rationalize.
Yep. So 2 square root of 5 over 5. Okay, so we've got cosine, we got tangent, we got cotangent, we obviously got secant. What do we need? Sine and
No.
Cosecant.
sine and cosecant. Okay, so we have a choice, but we're going to have to use a Pythagorean identity. We either have to use the sine plus cosine, right? Sine squared plus cosine squared equals 1, that one. Or we do have cotangent, and we know that 1 plus cotangent squared is cosecant squared. So which one do you guys want to find, sine or cosecant?
Cosecant.
Cosecant?
Yep.
Okay. So that identity was 1 plus cotangent squared equals cosecant squared, right?
Yeah.
So how am I going to just find cosecant? Do I have to move anything left or right?
Man.
Nope, I just have to take the what? The square root. Now, is the cosecant positive or negative in the third quadrant?
Negative.
Negative. Because it's the y, right? So it's going to be negative We already have it up here, 1 plus cotangent squared. So 1 plus, and you got to square your cotangent. I would suggest going back to this one, just because it's easier. So what's 2 squared? 4. What's the square root of 5 squared?
25.
So 5, because it's the square root of 25 is 5. So 1 is what?
5 over 5.
5 over 5. So I have negative the square root of 9 over 5, correct?
Wait,
Yeah.
how did you get the 4/5 again?
Because I squared the cotangent. 2 squared is 4. Square root of 5 squared is 5. Okay, what's the square root of 9?
3.
3. Square root. And the square root of 5 is going to be the square root of 5, so we can't leave it like that, can we? So it's going to be negative 3 square root of 5 over 5. So the last thing we need is what?
Sine.
Sine. So we know sine of u is 1 over the cosecant of u, correct? And I would suggest coming back to the unrationalized version as well, because it's really easy to reciprocate that, isn't it? Because if I reciprocated the rationalized one, I'd have to rationalize it again. So the reciprocal of negative 3 over the square root of 5 is what? Negative
Square root of 5 over 3.
negative square root of 5 over 3. Because I just reciprocated the cosecant. Now, let's see if we're right. So this was in the third quadrant, correct?
Yeah.
Okay. If it was secant,
No, not K.
if it was secant, it was x, no, it was the hypotenuse over the x,
Mm-hmm.
correct?
Yeah.
So it was negative 2, 3. So this would be 9 minus 4 is the square root of 5. And is that what we have with all those ones? Square root of 5. So I have the sine would be the square root of 5 over 3. And it'd be negative. Oh, I forgot my negative there. So I can check it that way. But today when you do them and then on your test, I'm going to say use identities. So do you have to show me you're using the identities?
Yes, ma'am.
Yes. Questions on what we did?
Why
Not
would
yet.
you square the 2 over the square root of 5 if it's in the square root?
What are you talking about?
For cosecant.
For cosecant, why would you take the square root? Because you have the square root right here.
No.
Oh.
The negative square root 1 plus the 2 over 3 root of 5 or whatever.
Because the identity is 1 plus cotangent squared. So you take your cotangent right here and square it. So 2 squared is 4, and the square root of 5 squared is 5. Questions? You're just going to be using these things and manipulating them. That's why you have 2 days to do it. And that's why you have so many problems to do. Because they're all going to be different, but you just need to be comfortable with manipulation. So I think I have like 1 or 2 more examples. Okay, it says simplify sine of x. And if I was writing it, I would have put sine of, parentheses around my x, cosine squared of x minus sine of x. So that means getting it down to one function, sine or cosine. So when I do this, I need to think about an identity that has sine and cosine in it. What is that?
Whatever those are called.
The Pythagorean identities. So we know that sine squared of x plus cosine squared of x equals what?
1.
1. So I can use this to change them into each other, can't I?
Yeah.
So do you think we should be changing sines into cosines or cosines into sines?
Cosine is sine.
Okay, why?
Because it's squared.
Because it's squared. Now I will have people tell me, well, you have more sines. Okay, yeah, you do have more sines, But cosine is squared, correct? And I definitely don't want to be putting square roots in there. That's not making this simpler, is it?
That's no good.
No, that's not making it simpler. So you want to start by making cosine squared, sine squared, or do you want to do maybe something different? Because I have one thing here and one thing here. What do they have in common?
Sine of x.
They have a sine, don't they? Okay. So could I factor out a sine of x?
Yeah.
Okay.
So I have sine of x, and then I would have cosine squared of x minus 1. Well, looking at this Pythagorean identity, could I make this into cosine squared minus 1? Could I rearrange it to make it say cosine squared minus 1? I couldn't?
Probably.
Could I subtract this 1 over here?
Oh, yeah.
Yeah? And if I subtracted the 1 over here, what would I have to do with the sign? Subtract it over here. So I would get cosine squared minus 1 equals what? Negative sine squared. So what can I replace this with? What did we just say that equaled?
Negative sine squared.
So now I have sine times negative sine squared. Well, what does that give me?
Negative sine to the sine cube.
It gives me negative sine cubed, doesn't it? Evan,
Yep.
you might want to look what we're doing.
Where'd you get the change?
Because this is to the first, yes?
Not the,
Yeah, go.
not the fruit. How'd you change the cosine of that sign?
Because,
Oh, never mind, I see it now.
yep. Now, if we would have, I'm going to come down here.
You solved it and plugged it in.
Yeah,
Like, so is that the answer?
yep, that's simplified. So what if,
That's it?
yep,
Huh.
what if we replace that cosine first? Think about what would have happened.
We would have
So
to
we would
square
have-
root the both.
No, we wouldn't have to because it's cosine squared, correct? So wouldn't we just subtract this over here?
Yeah.
Yeah. So we would have sine times 1 minus sine squared minus what? Sine squared? Oh, just sine, not squared. Then what would we have had to do? What would we have had to do with this right here?
Multiply.
We would have had to distribute it, right? So then we would have had sine
Of x
Of x.
minus sine cubed of x
And then
minus sine
of
of x. Well, sine of x's would just,
and these would zero out.
yeah,
So I would have got what?
negative
Negative
sine
sine.
cubed of x, same thing.
So when you guys come with me with a question tomorrow, I'm going to say, what did you do? What was your first choice? Because could I have done this 2 different ways? Yeah. Some problems you could have gone 3, 4 different ways. You have to find what works for you. But how did we know to go to this Pythagorean identity?
Because you have a sine and a cosine.
Because we have a sine and a cosine, and you also have a what? Squared. Anytime you see a function squared, your brain should be going Pythagorean, 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 like thinking, what do I do with that? Okay?
For the
Yeah.
Pythagoreans, you have 1 plus tangent squared equals secant squared. What if you get a cosecant secant squared?
If you get a cosecant and a secant squared, you would have to do more manipulation. It wouldn't be a straightforward identity. You'd have to probably change them into sine and cosines and then go from there.
Will the book have one where it's like that?
Probably. But you know that cosecant is 1 over sine, correct? So cosecant squared would be 1 over sine squared. And you could get common denominators, you could do multiplication. So you're going to be just changing things into what you know and just doing your math on them. It's going to get your brain over, that's ugly, I can't do it. You know what I mean?
Possibly work it out if we have enough time.
We may have one. We may not. Okay. Rewrite 1 over 1 plus sine. One of the cues, guys, is if you've done something on a previous problem that looks similar, you maybe should try it. Does that make sense? These problems will gradually get more complex. They won't just jump into the deep end. So if you start looking back and say, oh, wait, I think I did something like this. What did I do? Duplicate what worked. Okay? So this one says write it not
In fractional form.
as a fraction.
So then you just multiply that by the reciprocal.
Well, I don't have an equal sign, so I can't do a reciprocal. But I can do something you guys have done before. And it's kind of what you mean by reciprocal. And you guys will notice that I don't always put my x's at the beginning, like through my work, but it has to be at the end. Does that make sense? What if I multiplied the bottom and the top? Because I don't have an equal sign, I'm not solving. I'm manipulating. What did I just multiply that by?
Difference of squares.
Difference of squares, or starts with the C.
Conjugate.
Conjugate. And when I have 1 minus sine over 1 minus sine, is that really only multiplying by 1?
Yeah.
Yes. So in the numerator, I'm going to get 1 minus sine. And in the denominator, I do have the difference of squares. So I don't have to FOIL that all out to know that the middle two terms are going to 0, do I? What's that going to give me? 1 minus sine times 1 plus sine.
1.
It's going to be 1 minus sine squared.
Then would you take the square root and rationalize?
No, we don't want to take square root, because then that's like making the square. With our whole thing is not as a fraction, so I need to get no denominator, right? So what could I make 1 minus sine squared into?
1 minus sine squared. 1.
What identity has a sine squared and a 1?
1 minus the difference of squares. Could you do that?
No, because we just took it out of that.
Oh, okay.
What identity has sine squared?
Oh,
The Pythagorean. Cosine squared plus sine squared equals what?
1.
1. Now you notice I've been writing sine squared plus cosine squared equals 1, and I switched that around. Does it matter with addition? No. Okay, so what would 1 minus sine squared equal looking at the Pythagorean identity?
You have to subtract sine squared.
You would have to. So this would equal 1 minus sine squared would equal
Cosine squared.
cosine squared. See how we're manipulating that now? This is not a fraction. I'm going to get rid of that. It's not a fraction. Do you see how we're just manipulating that one thing? So that gave me 1 minus sine over cosine squared, didn't it? Okay. But it still says not as a what? Fraction. Okay, so just as we can add two fractions together, can I pull them apart? Okay, so if I pulled this apart, it would be 1 over cosine squared minus what? Sine over cosine squared. Well, what is 1 over cosine?
Secant.
Secant, right? So wouldn't 1 over cosine squared just be secant squared? Okay, so secant squared. We got that one. Well, gosh darn it, it's not. If it was sine squared over cosine squared, that'd be easy. It'd be tangent squared, wouldn't it? But it's not. So can I rewrite it as multiplication of two things? Could I have sine over cosine times 1 over cosine? Yeah. Could I have it sine times 1 over cosine squared? Could I have that? Okay. So again, I have multiple things I could have, don't I? Which one would you guys like to have? Would you like to do 1 sine over cosine times 1 over cosine, or do you want to do sine times 1 over cosine squared?
One cosine squared.
Okay, because that's similar to the other one, isn't it? Okay, so I'm going to come up here. So that would give me secant squared x, because I think I'm getting close, so I probably should put back my x, right? Minus sine of x times secant x again. Oh, secant squared x. Because this 1 over cosine isn't 1 over cosine squared. Isn't that secant squared?
Oh, yeah.
Yes. Now, all it says is not fractional form. Did we get it out of fractions?
Yes.
Yeah. Could we factor out a secant squared if we wanted to?
Yeah, but why do we do
I don't know. Let's see what happens. So I would get what? 1 minus sine squared? Now, if that's sine, not sine squared, 1 minus sine, right? My brain was, we're not leaving anyway because they're testing. It's 1 minus sine, and they did not announce that. We should not be moving classes.
What are they testing?
They're doing NSCAT testing.
And scat.
Yeah. It's, yeah. Okay, but anyway,
But wait, what if they complete?
I don't know that, we'll check. But we could have this or what? That? But did it still get our non-fractional form? Yes. And I think that's our last example. Yep. They must be done testing.